Hi, Dave Lee here, commercial aviator, thermographer, and Part 107 drone pilot. Welcome to FLIR Delta, a new video series dedicated to helping you effectively integrate thermal imaging into your work. Our goal is to help you better understand and properly use thermal imaging from your drones so you can be more efficient, effective, and improve your business. We're going to cover everything from infrared fundamentals to solar panel and commercial roof inspections to how to choose the right color palette for your mission. I've been a drone pilot for a decade, a thermographer for 20 years, and a commercial pilot for nearly 30 years. Plus, I've trained hundreds of airplane and helicopter flight crews around the world how to use infrared cameras in their critical, life-saving missions. So let's put some of that experience to work and help you get the most out of your drone thermal camera. Let's get started. Thermal cameras let us see invisible, thermal, or infrared energy that's around us all the time. Infrared energy is part of the electromagnetic spectrum. This energy is around us all the time, but we don't think about it because it's invisible to the naked eye, except for a tiny slice in the middle we call visible light. Even though it's all light energy, visible light and thermal energy don't always act the same. Our eyes see light that has reflected off a surface. It reflects in different wavelengths, and this makes the color differences we see. But thermal energy doesn't work that way. It can be given off, emitted, or reflected. Visible light passes right through glass, but thermal energy doesn't. Not only will most of the energy you'll see from a drone be emitted or reflected, it can even be both at the same time. When we talk about how efficiently an object gives off its thermal energy, we're talking about its emissivity. Different objects give off or reflect thermal energy differently based on what they're made of and their surface condition. People, animals, concrete, trees, and rocks have high emissivity, so they give off their energy very efficiently. Materials like shiny metals typically have low emissivity, so they're reflective. But a metal's emissivity can change if it's corroded or painted. When two objects are close in temperature but have different emissivity, they can appear very different to a thermal camera. This roof is made of the same metal material, but the section on the left is new and hasn't been painted yet, so it's reflecting the cold sky. And a clear sky, or its reflection, is going to be the coldest thing you're likely to see from a drone. Something else to keep in mind is that thermal imaging is largely a surface phenomenon. For the most part, thermal cameras don't see through anything. They don't see through glass, and they don't see through walls. But heat moves. People will look at this picture and think they're seeing through the roofing material, but really what they're seeing is the heat transfer between the trusses and stringers and the metal of the roof. So now you've got an idea of the many factors that can impact how things look to a thermal imager on a drone. It's not just how hot a thing is, but what it's made of, its surface conditions, what it's close to, and what it's touching. These can all influence how it appears to a thermal camera. Knowing how to interpret thermal images and collecting accurate temperature measurements is an art form all its own. So check out the Infrared Training Center at infraredtraining.com. They've got lots of good information online, and they are the industry's go-to source for professional thermography training and certification. So that's it for this episode of FLIR Delta. There's a lot more to learn, so keep checking back for new episodes and free helpful downloads at FLIR.com/Delta. We'd like to thank our friends at Aerodrone Academy for their help in producing this video. Check out their link in the description. Thanks for watching, fly safe, and I'll see you on the next episode of FLIR Delta.